Imagine putting on your VR headset and it just instantly knows it's you. Not because you typed in a password or, I don't know, scanned your retina, but because it can actually feel the unique microscopic acoustic echo of your own heartbeat bouncing off the inside of your skull.
It sounds totally like science fiction, but it is a reality we are unpacking today.
Welcome to episode 467 of AI Brief. Today we're doing a deep dive into some absolutely massive updates. I am Amin.
And I am Leah.
We have a huge roadmap to cover for you today. We are looking at a fundamental shift in global computing power, starting with DeepSeek's massive hardware pivot to run their upcoming V4 model entirely on Huawei chips.
Plus, we'll explore some absolute frontiers of human achievement. Everything from Artemis II pushing humanity further into deep space than ever before, to genetic treatments literally reprogramming our inner ear biology to reverse deafness.
And finally, we will break down a whole new wave of AI tools that are actively erasing the friction from your daily workflows.
We are tracking a major realignment today. It's happening at the macro level of global data centers, all the way down to the micro level of our skeletal structure.
So let's jump straight into the hardware shift that has basically the entire tech industry paying attention. DeepSeek, the Chinese tech company behind some of the most incredibly efficient AI models we've seen, is launching its next generation V4 model in just a few weeks.
But the real story isn't just the model itself. It's the architecture underneath it. DeepSeek previously worked closely with U.S. chip makers to train and run their models. But now they're fully utilizing Huawei Technology's latest chips.
This is a monumental pivot. DeepSeek hasn't just bought new hardware. They've been actively working alongside Huawei and another domestic chip designer called Cambricon Technologies.
To do what, exactly? Like hyper-optimizing the V4 model's code specifically for this new Chinese silicon.
Yes, they are doing what we call bare metal optimization. When you optimize AI software at that foundational level for a specific physical chip, you bypass all those clunky translation layers.
You unlock incredible performance efficiencies that you honestly just can't get when you're using off-the-shelf, generalized components.
It's like a car manufacturer suddenly deciding to build every single engine component completely in-house rather than importing them.
Oh, that's a brilliant way to look at it.
If you buy spark plugs, pistons, and fuel lines from 5 different global suppliers, your engine will definitely work.
Yeah.
But it's built on a series of compromises to ensure all those different parts fit together.
At the moment you design the engine block and the software that manages the fuel injection at the exact same time, perfectly tailored for each other,
you completely change the horsepower you can output. And that's exactly how the architecture works here.
it highlights a massive trend of reducing dependence on U.S. technology. By aligning their software development directly with Huawei and Cambricon's hardware cycles, they are proving that a highly optimized, entirely domestic, closed-loop AI ecosystem is forming.
And the market reaction is immediate. We are seeing Chinese tech giants like Alibaba, ByteDance, and Tencent already placing massive bulk orders for Huawei's upcoming chip.
We need to emphasize what a bulk order means in this context. These companies operate some of the largest data centers on the planet.
An order from Alibaba or Tencent represents hundreds of millions of dollars in raw infrastructure investment.
They are placing these huge bets because they see the benchmark potential of DeepSeek V4 running natively on this optimized silicon. It's a clear signal to the global market that the bottleneck of relying on imported hardware is being actively engineered out of the equation.
Well, energy consumption and latency are the two biggest costs in any data center. If your software and hardware are speaking the exact same native language without any middleman, you use less power to compute the same amount of data.
The broader business implication here is the fragmentation of the global AI landscape. For the past decade, we had a relatively unified global supply chain for high-performance computing.
Now, we are seeing the maturation of parallel ecosystems. The fact that V4 rolls out in just a few weeks means we will very soon have direct, real-world data on how this closed-loop hardware actually performs against the established U.S.-based chip infrastructure.
We are moving from a model of global interdependence to highly optimized, vertically integrated regional powerhouses. It is going to be fascinating to watch those benchmark numbers drop.
But let's widen our lens a bit now.
Mm-hmm.
We're stepping away from the rapid iteration of global tech infrastructure and looking at where humanity is pushing its physical boundaries.
We're going to slow down the pace a bit here because the scale of these next developments really requires a moment to just appreciate.
On April 1st, NASA's Artemis II, successfully blasted off from the Kennedy Space Center.
We are talking about 4 astronauts currently on a trajectory that will take them further into deep space than any human being has ever traveled in history.
It's the first crewed lunar mission in 54 years. When you consider the sheer mathematical precision required to launch a vessel from Earth, establish a free return lunar trajectory, and sustain human life in the total vacuum of deep space, it is staggering.
We have grown entirely accustomed to launching satellites and autonomous rovers. But a rover doesn't need to breathe.
It certainly doesn't.
It doesn't need climate control or radiation shielding in the same way. Placing a human crew back into that extreme environment represents a monumental leap in modern aerospace engineering.
We're looking outward, pushing the absolute macro limits of our physical reach with Artemis. But at the exact same time, we're pushing inward. We're exploring the absolute micro limits of our own biology.
Scientists have just published the results of a landmark gene therapy trial focused on reversing deafness.
10 patients, all suffering from varying degrees of severe hearing loss, received a highly specialized injection.
This treatment delivered a working copy of something called the OTOF gene directly into their inner ear.
The mechanics of this are incredible. The ear is essentially a mechanical sensor that turns air pressure into electrical signals.
And the OTOF gene is responsible for producing a protein called otoferlin. You can think of otoferlin as the crucial bridge that allows the sensory cells in the ear to actually communicate with the auditory nerve.
So without that protein, the ear detects the sound mechanically, but the bridge is out. The brain never receives the signal.
By injecting a functioning copy of the gene, scientists essentially dropped in new blueprints. It allows the body to manufacture that missing protein and rebuild the bridge.
The delivery mechanism is fascinating too. They use a harmless viral vector, basically a microscopic delivery truck, to drop the correct DNA sequence straight into the inner ear cells.
And the data from this trial is unprecedented. Every single one of the 10 patients saw major improvements.
To quantify that, their average sound detection threshold improved from 106 decibels all the way down to 52 decibels.
To really put those numbers into perspective, 106 decibels is the equivalent of standing right next to a jackhammer or a roaring motorcycle.
That was the absolute minimum volume required for them to register any sound at all. Dropping that threshold to 52 decibels means they can now hear the volume of a quiet, normal conversation at home, or the hum of a refrigerator.
That is a life-altering restoration of sensory input, and the success rate here provides a validated blueprint for the future.
Because the delivery mechanism into the inner ear works so flawlessly, researchers are already looking at other genetic targets.
They are preparing to address mutations in the GJB2 and TMC1 genes next. Those are responsible for different structural causes of deafness.
We are literally entering an era where biological mechanical failures can be reprogrammed at the source code level.
That concept of biological hardware connects directly to another breakthrough, but this one uses the physical acoustics of the human head to solve a digital problem.
Scientists at Rutgers University have developed a biometric login system called VitalLead, and it essentially uses your skull as a password.
It's a brilliant application of acoustics. The system authenticates your identity by utilizing the unique vibrations created inside your skull by your breathing and your heartbeat.
Your bone structure acts as a highly specific acoustic chamber. Every time your heart beats or you draw a breath, micro-vibrations travel through your skeletal structure.
Because everyone's bone density, thickness, and cranial shape are entirely different, that vibration signature is completely unique to you.
Okay, let me push back on how practical this is in the real world, though.
Yeah.
What if I just sprinted up a flight of stairs? I'm completely out of breath. My heart is pounding at 140 beats per minute. Does my VR headset lock me out because my pulse is suddenly elevated and the rhythm changed?
That is a great question. And it's exactly the hurdle the engineering team had to solve. The system does not authenticate based on the speed of your heart rate or the pace of your breathing.
What does it measure then?
It measures the physical resonance of the acoustic wave as it travels through your specific bone structure. Think of it like a guitar. If you pluck a guitar string, it makes a specific sound because of the shape of the guitar's wooden body.
And plucking the string faster doesn't change the shape of the guitar.
That makes perfect sense. In this case, the pitch and frequency of the vibration echoing through your skull remain constant, whether your heart is beating at 60 beats per minute or 140. The shape of the echo chamber doesn't change just because the drum is being beaten faster.
The skull is basically acting like a fingerprint made of sound, and the data backs up the precision of this approach.
Over a 10-month testing period with 52 different users, Vitali successfully authenticated the correct person over 95% of the time.
More importantly, it blocked imposters 98% of the time. The team at Rutgers is pitching this as the absolute future of frictionless login for virtual reality and augmented reality headsets.
You put the device on your head, it passively feels the biological resonance of your skull, and you are instantly logged in.
It represents a total shift away from external security measures, like typing a string of characters or scanning a fingerprint, toward continuous passive biological authentication. The friction of proving who you are simply vanishes.
Taking that concept of erasing friction, let's bring things back to the immediate, practical tools you can deploy right now.
I am ready for a rundown of the top trending AI tools designed to accelerate your daily workflow.
We are seeing a major evolution here. We're moving past tools that just generate text and entering an explosion of highly specialized agents that handle complex, multi-step processes completely autonomously.
First up is Influcio. This is an AI marketing agent built entirely for result-driven influencer campaigns.
Instead of a marketer spending hours scrolling through social media hunting for content creators, Influcio automates the entire tedious outreach funnel.
You give it your campaign goals, and it actively finds perfectly matched creators. But it doesn't stop there.
It drafts the personalized outreach emails, negotiates the deliverables, and tracks the responses. It's not a search engine, it's an autonomous project manager executing the workflow for you.
Next on the list is a fascinating tool called Panorama. This is an AI designed to uncover your team's actual workflows and hidden structures.
I absolutely love the use case for this one. Think about how a remote team operates. The official organizational chart might say that marketing reports to sales, but that's just an aspirational diagram.
Panorama maps out how the team actually collaborates based on communication patterns, shared documents, and meeting overlaps. It reveals who the real hubs of information are.
If one junior designer is secretly answering questions for 5 different departments, Panorama highlights that hidden bottleneck. It helps managers understand the true organic structure of their workforce.
For developers and global users, we have TinyAya. This is a local, open-weight AI designed specifically for real-world languages.
The massive advantage of TinyAya is that it runs natively on your machine without needing a cloud connection. We're talking about the shift from cloud computing to edge computing.
If you are traveling offline or working with highly sensitive corporate documents, you can run fast, private, and highly accurate language translations entirely on your laptop's own silicon.
It brings heavy-duty language processing directly to your local hardware with zero latency.
Moving into personal optimization, there is Ember. Ember functions as a meal scanner, macro tracker, and AI coach, all rolled into one seamless interface.
The computer vision here is what makes it frictionless. You don't have to manually type 100 grams of chicken and half an avocado into a database.
You simply snap a picture of your lunch. Ember analyzes the image, calculates the volume, instantly provides a detailed nutritional breakdown of the proteins, fats, and carbohydrates, and then cross-references that data with your personal fitness goals to offer real-time coaching advice.
It removes all the data entry friction from personal health tracking.
Finally, for the developers and designers out there, we have the Handle extension. This is a tool that allows you to refine user interfaces directly in the browser and feed those changes straight back to your coding agent.
It essentially collapses the gap between visual design and the back-end code base. Usually, a designer tweaks a button's placement, copies the visual code, and hands it off to a developer to rebuild in the back-end.
With Handle, you can literally drag and drop a button on a live website to see how it looks. Once you find the perfect placement, the extension automatically writes the back-end code to make that change permanent across your application.
You change the surface, and the AI rewires the plumbing underneath. All of these tools illustrate how AI is moving from a novelty to an embedded, invisible layer of everyday productivity.
We are just expecting the software to execute the heavy lifting. And when you pull all of these threads together, from software that writes its own back-end code, to inner ear injections that rewrite our DNA, to passwords generated by the acoustic echo of our own bones, you start to see a very clear picture.
The boundaries between our physical bodies and our digital lives are basically dissolving.
Which leaves us with a fascinating thought. If your skull's unique acoustic signature becomes the ultimate password, what happens if that biological signature is somehow intercepted or replicated?
You can't just reset your bone structure like you change a leaked password.
As our most immutable physical traits become digital keys, it introduces a completely new paradigm for how we secure our identity in the physical world. It's something to think about the next time you put on a headset.
The pace of these advancements requires us to constantly update our baseline understanding of what is technologically possible.
If you want to stay ahead of that curve, make sure you follow the podcast. And please share this deep dive with a friend who loves exploring the absolute bleeding edge of technology and science.
See you in the next episode.